In this video, we'll talk about Kafka Rebalancing protocol. First, we'll understand the eager protocol. Then we'll look at problems with eager protocol. And lastly, we'll look at this new incremental cooperative protocol and how it solves some of the problems with the eager protocol. So before understanding a partition rebalancing protocol, first let's understand some of the concepts. One is group coordinator. For a consumer group to work fine, there is a group coordinator which is played by a broker, right? So one of the broker in the Kafka cluster would act as a group coordinator to one of the consumer group or multiple such consumer group, right? And to assign those partitions to these consumers in a consumer group, one of the consumer will take that responsibility by becoming the group owner. So these two concepts are very important, group owner and group coordinator, right? Why the group owner is part of consumer group or consumers code rather than a broker code? Because Kafka wants to decouple these two things, that there could be a central coordinator, but as your consumers change, you might have newer protocols to do those things. So that ownership of repartitioning is remained with consumers. In this example, we'll see what happens when consumer C3 will join a consumer group which already has C1 and C2 as their consumers. So when C3 will send a join group request to group coordinator, right? Group coordinator will see, okay, now everybody has to rejoin this group. And how it communicates this to C1 and C2 is when C1 and C2 sends a heartbeat to group coordinator, they'll get a response saying you need to revoke your partitions and rejoin. At this point, they'll revoke their partitions and send a join group request again, right? On this join group request, it will say to everybody, okay, only to reassign those partitions to all the consumers, but only the group owner, which was chosen by group coordinator only, will reassign those partitions, right? As soon as people receive this messages that you need to reassign those partitions, they'll again send a sync group request to the coordinator. The C1, which is the group owner, will actually do the reassigning of the partition and send the sync group request again with the new partition assignment. After this, the coordinator will send a response to every consumer with the new partitions that are assigned to them. So in this case, we see that from this time where the partitions were revoked to this time where the partitions were assigned, none of the partitions were actually being worked upon. And this is one of the major problems with the eager protocol. Why? Because in this case, even though only some of the partitions needs to be reassigned to C3, but the work has stopped in all of those partitions from starting of this revoking to when they are completely assigned. And this particular problem where this stop the world happens for all the partitions, whether they are needs to be reassigned to other consumer or not, is the problem that is actually solved by the cooperative incremental protocol. And let's see how that protocol solves the problem. So now we will learn how this new Kafka incremental cooperative protocol works and how this solved the stop the world problem. So we'll take the same example where C1 and C2 are part of the group earlier and C3 joins new in this group, right? So initially again this the same the flow would be same. C3 will send a join group request to the group coordinator, and group coordinator will see, okay, now I want other group members to also rejoin. It will wait for the heartbeat. So now C2 sends an heartbeat and C1 also sends an heartbeat. It will ask all of them to uh, say send a join group request again, right? But in this case, interestingly, none of them is actually revoking any such partition, right? So after it receives a join group request from C1 and C2, right, it will send the group owner, which is C1, to reassign these partitions. What C1 would do, it will take some of the partitions away from C1 and C2, but will not assign them to C3. So it will send the response of assigning to the group coordinator, and based on it, this group coordinator will say to C1 and C2, okay, revoke these partitions, which is 3 and 6. But partition 1, 2, and 2, 4, 5 are still assigned to C1 and C2, right? After they revoke this partition 3 and 6, they will again send a join group request, all of them, C1, C2, and C3, right? In this case, they will send with this information saying uh, C1 has 1, 2, C2 has 4, 5, and C3 has none, right? And then C1 takes a decision, okay, these 3 and 6 partition are not assigned to anybody when I last reassigned it, right? So it will assign those partition to consumer C3, right? So now C3 in this response will get 3 and 6 partitions, and for the sync group request which was sent by everybody, they will get a response again where C1 will see nothing changed for me, C2 will also see nothing changed for me, but C3 will see that he got assigned partition 3 and 6. So in this case, fundamentally what happened is there are 6 partitions, but only partition 3 and 6 were affected from this point where the partition got revoked, right, to the point where partition got reassigned, right? So if you see the duration of again this revoking to reassigning looks similar to the eager protocol, but the difference here is that partitions that are assigned to consumer 3 are the only one which were affected rather than